This is Møller Nielsen from Java Geeks, and I'm going to teach you how to write clean, efficient code with encapsulation. With the encapsulation, we can decide which fields should be read-only. We can also change the scope of each field. Complementary to this video, we have a lot of guides in our website, so that you feel free to go and look at those. And also, if you like these videos, then remember to subscribe, like, and hit that notification bell so you know when the next video is coming up. Now, without further ado, let's get started. For this demonstration, I'm using IntelliJ, and I'm using Java 15. And I created a project by pressing File, New Project. Then I chose Spring Initializer, I chose JDK 15, and I chose a distribution called Azul Zulu, which is an open JDK distribution. Then I pressed Next. Then I chose Gradle just because I prefer Gradle, but if you prefer Maven, then just choose Maven instead. I chose Java 15 there. I pressed Next. I ticked off Lombok because when we are talking about encapsulation, then Lombok has some really convenient annotations that can actually help us be more efficient in our daily work. Then I added Spring Web just because if I want to have a web server, then I would also have that. Then I pressed Next, I gave it a good name, and then I pressed Finish in the end. Then I got this project right here, and let's get started. I'm going to create a new package called Space, because we're going to create a spaceship today. So here we have Space. I'm going to create a new class named Spaceship. So this is my spaceship. And if we do not use encapsulation, maybe we'll just have some public fields like public string and then the model of the spaceship. It could be like if it's round or if it's pyramid shaped. Then we can have public string captain. So this is the captain, the name of the captain of this spaceship right here. And then we have an integer, which is a whole number regarding the fuel percentage that we have left. So right now we are not using encapsulation. That means that we can actually access all these three member variables right here directly. And let me create a test. If I put the cursor in the end of the name of the class name and press Alt Enter, then I can choose Create Tests. And I choose JUnit 5. And then I pressed OK right here. I'm adding it to Git. That's okay. And now I can create my test method right here. Public void try stuff. Like this. Then I need to annotate my test class with add test. And here you can see that I'm using JUnit 5 and not 4 because it has the Jupiter package name. It has Jupiter in the package name. Jupiter is the 5th planet from in the solar system, and that's why the people behind JUnit 5 they chose Jupiter to be a part of the package name. So there will be no confusion whether people are using JUnit 4 or JUnit 5. Okay, so now we will create a new spaceship class like this. We're using the default constructor. We do not create any constructor ourselves, so that means that we only have a default constructor. And then I can set the captain to something like Mike. I can set the model to something. It could be a round spaceship. And then we are going to set the fuel percentage to 77%, like this. And that's all good. We are allowed to do this, and we can also create an assertions, assert equal, and then we can say that we assert that the fuel percentage should be 77%, like this. A good test always have assertions in them. And that's why also, if you want to write testable code, you should always make your methods return something because it's much easier to assert and test something when you have a return value. This test is green, everything went fine, and we are happy. But let's say we want to, we do not want people to suddenly to change the model The model, it should only be set when we are creating a new instance of the spaceship. And this is where encapsulation comes in, because now we can actually use encapsulation to say that we cannot set the value of model. And the way we do that is actually, to begin with, we will start with changing the scope from public to private, like this. So now it's private. And private. If we want the model to be set, and now we get some errors, and that is because our unit test now fail, or there's compilation errors in the unit test, because now these member variables are not accessible directly. But this is on purpose that we're doing this. So we have private string model. If we only want the model to be set once, then we can also add final. So that means that it will only be set once. But in this example, let us just keep it so it's not final, so we can actually reset it if we actually want to. Then I want to create some getters and setters, and there are multiple ways to do that. If you press Alt Insert if you're using IntelliJ and you press Alt Insert, then you can actually see right here that we get the opportunity to generate code, and I can choose getters and setters. If I want to make all of my fields read-only, then I will only use the getters. But for now, let us just use getters and setters like this. And we choose all of our member variables, press Enter. And now we got our getters and setters generated for us, which is much easier than if we had to create this code by ourselves. Let us go back to our test now, because we need to fix our test. So first of all, let us create a constructor that actually matches all the fields. Again, I can generate this code by pressing Alt Insert, Constructor. Then I can choose my 3 member variables. Then I can create a constructor based on my fields. So let me go back to my spaceship right here. Now I can see, if I press Ctrl P, then I can see which parameters that my constructor takes. And here it takes a model, so that means I need to write round. And let me just close the Gradle window on the right side. We don't need that right now. Then we have the captain. That could be Mike again. Then we have the fuel percentage. Let us set that to 88 this time. And let me delete this code right here. I'm pressing Ctrl Y in IntelliJ. Then I delete the whole line at a time. And then I expect the fuel to be 88%, and I access the fuel member variable with a getter. That is because we are using encapsulation. So let us run this program right here. We run the test right here, and then now we have a green test, and there's no errors, and we're actually happy. But the reason why we actually wanted to use encapsulation was that we want now to set. We want to say that we cannot actually. We cannot set the model anymore. We can only set the model when we are actually constructing the spaceship. So, but first of all, let us create an assertion, and that is that the model is round. So then we will say get model like this, and we will also take our spaceship, and then we will set the model to something else, like it could be something like a pyramid. Now we have a pyramid spaceship. Of course, then we would also expect the spaceship here right down here to be of the pyramid model. So let us run the test again just to see that it still runs and it's green. Yes, it's green and it runs. Now we will actually remove the setter from the spaceship, because we do not want people to go around and set the model. So we will actually just delete this code right here. And now it's not possible to set the model anymore, except for when we create the instance. So when we create an instance of the spaceship, yes, then we can set a model, and now we get a compile error, because this method right here, it does not exist anymore. We just deleted it. That means that we need to set pyramid when we are setting the spaceship like this. And let us run our test once again. And it's green, and we can actually now see that we have actually encapsulated the fields, the data that we have inside of our spaceship, so we can only access them with methods and also with the constructor, of course. Another good use for encapsulation is actually that you could create functionality, so the whole object is actually read-only if you want to. So we can actually create a boolean, create boolean, private boolean, and then we can say read-only. We can also give it a default value, which is false. And then we can actually say that if we try to set the captain, if read-only, then we can create our own exception. Of course, we can create our own. Runtime exception. Let us actually do that. So I'll create my own. This object is read-only. Read-only exception like this. So now I'm creating my own custom exception. Extends exception. We could also extend the runtime exception like this. And let us just keep it with that. Then we get a default constructor for it. And then we say if read-only, throw new this object is read-only exception like this. And of course we could do the same for the other setters. Also down with the fuel right here. Here we have the fuel. Set fuel, and then if it's set to read-only, then we would actually throw this exception instead of setting the value. But now we cannot, let us create accessors. Again, I press else insert to generate code, and then I can create getters and setters again. And this time I choose my read-only field. So first of all, I get a method where I can ask, is this read-only? And I can also set read-only to a value if that's what I want to, like this. So what am I going to do now? I'm going to take the spaceship. Then I'm going to give it a new captain, set captain, and this time could be Susan instead. And assert equals. It's good to assert something always, so let us assert that the captain of the spaceship is Susan, like this, and then we run the test just to see that it actually works. It actually works, it runs. So now I'll take my spaceship dot set read-only like this to true, and let us see what happens now. Oh, now we got a red test. We got an exception right here. This object is read-only exception because we just set the whole object to read-only, and now we're trying to set the captain to Susan. So this is another use case for encapsulation. Another use case for encapsulation is that if we want to do something when we set the captain, instead of just setting the captain, we could actually also run other code. But if you want to keep your program straightforward, then you should keep the code in the setters and the getters to a minimum. Another use case could also be that we want to log whenever some code is going to access the fields. Then we can actually add. This is a Lombok annotation SL4J. That means that now I will have a logger available to me. So that means that every time we get the captain, then I would like to log that now some other class is using this. Is actually accessing this data. The captain is being accessed, and we could also add the value actually in the log. So that means that now when we are accessing, let us set read only to false again, so we don't get the exception. We could also just leave it at the default value, which is also false. But now when we are getting the captain in the last line right here, then we can actually see that we have a log statement right here. The captain is being accessed, and the value was Susan. So that is another good use case for encapsulation. Yes. So let us try to look at Lombok, because all of this, you can see all of this code is actually, most of it is boilerplate. And it's very annoying for us that we actually have to write all of this code. So now I want to delete all of these getters and setters because I want to use Lombok, which helps us being more efficient. Of course, now we also deleted the read-only functionality, which is okay. But Lombok helps us in a lot of ways. Let us say that we want Lombok to create the getters. Then we can actually annotate with then we can actually annotate with getter, and we can do this on the field level. So that means that if I want to create a getter for the captain, then I can do that. If I want to create a constructor, then I can annotate with all args constructor. That means now a constructor will be created for us, containing all of the arguments and all of the fields. The benefit of using Lombok instead of actually writing this code yourself is actually if you change something, if you add a new field, if you add a new member variable, then it will be automatically be added. There will be automatically the constructor will automatically be changed, so it also have this new member variable in it. So that's a huge benefit. But we can actually add getter, and we can also add setter like this. And then we can go to our test again. Now read only does not exist anymore, and now we can actually see that we get compiler errors with the model and the fuel because there are no getters for those, but we have a getter for the captain, and we can also set the captain. So let us just go back and add this functionality also for our model and for the fuel also. Now we're just adding getters because we do not want it to be. We can actually also add a setter for the fuel. So now we have the functionality we started talking about in the beginning, where we can actually we can only set the model when we are initializing, when we're creating a new instance of the model. And then after that, we can only get the model. We cannot set the model. So let us go back to our spaceship, and now it's actually green because Lombok is actually creating the code for us. If we are curious about what actually happens, then I can go to the build folder. And this is because I'm using Gradle, then it's the build folder. Then I can go to the classes file. I can find my spaceship. And then I can say that I want it to be decompiled by double-clicking on it. And here I can see that Lombok actually created the same methods that we just created ourselves when we wanted to encapsulate this class, right? So Lombok just did all of this work for us. So thank you very much for that, Lombok. And here we can also see that it created a constructor for us, and it also created a logger that we can use to that we use to log whenever the captain was accessed. We do not do that right now, but of course we could add that functionality again. Another thing I want to show you is that we can actually, instead of having all of these getters and setters, let's say that we want getters and setters on all of the fields. If you want the same functionality of all the fields, then there's actually an annotation called data, Lombok data. This will create getters and setters, and it will also create a good equals method that will actually look at all of the values right here. If these are equal, then the two objects are also equal. It will also create a good toString method, and it will also override the hash code method. Data, let us start with that actually, and go back to our test. Because what we can do now is actually that we can print out the spaceship, and we can also see that the code still works, that we do not have any compilation errors. We need to notice right now that now we actually have the same functionality for all of the fields. We can also set the model if we want to. So that means that we can actually set the model to something else like a cube or something like that. Let us do that after the assertion so we don't get an assertion error. And now I can print out my spaceship because we also got a good toString method right here. And here we can see this is the toString method that Lombok actually created for us. Another cool thing with Lombok and encapsulation is the accessors. And I know it is an experimental package, but it has been there for some time, so I think they will keep it actually there. Inside the accessors, we can actually choose that we want to have, we can set chain to true. And what does that mean? That means that every time we set a value, then the spaceship will actually be returned. And then we can actually set a new value. And let me just demonstrate this. I really like this functionality. So let us say that I want to set the model, but I want to set the captain, but I also want to set the model. Then now, because I chose chain, then I can also write set model like this, and then we can choose cube. And then I can also say set fuel, and we can actually fuel it up to 100%. And this is because if we look at the code now, then if we look at the code right now, Then in the setters, we are actually being, we need to recompile it. Let me just do that. Recompile the file. If we go back to the spaceship right there, then we can actually see that now on all the setters, we're actually returning this. So instead of just returning instead of not returning anything, because before it was void, now we actually return the spaceship. And this is pretty useful. This is pretty useful, and it makes the code much more. It makes it much more concise. And some people actually they choose to set a new line for each set statement like this, so we can actually say that we have the spaceship, then we're setting all of the variables one by one like this. And of course, we also need to change our unit test now, so we assert that it's a cube. Okay, so and let us just run the test to see that it actually shows green. Oh, there was actually an assertion error right here. We asserted 88, but the value was actually 100, so let us set it to 100 like this. And now it's green again. Pretty cool. Another thing I want to show you is if we go to accessors, then there was another property we could set, which is the fluent. If I set fluent to true, let us see what happens then. Now we get some compile errors, and that is because now it's not called set captain, now it's just called captain. So it means that the set has been removed, and that also means that the getters has been removed. So that means that it actually just it just means that the method has been renamed to that was fuel, this one right here. And also the getters, then the get has been removed, and that is what fluent means, that then it will just rename. So the methods has the same name as the fields without the get and the set in front. And this is the normal way actually to create a program. You don't have to use to write the get or set explicitly. You can just give an argument to the method. Then you know that then you're using the setter. If there's no argument, then it is actually the getter, like we do right here. Let us try to first let us run the test and see that everything actually works as it should. It did. Then I want to recompile the spaceship, so I can go and decompile it afterwards right here. And here we can actually see that now the methods are named model, and let us see if we can find the getter. So we have that was the right idea. Here we have the getter. So here we have this is a method without any arguments, and then we just return the value like this. I hope you enjoyed this video. If you did, then make sure that you smash that like button, hit the notification bell, and also subscribe, because we have a lot of cool things coming up. Bye.